note down this question. So today we are going to solve some problems related to the unsymmetrical faults. In the previous lecture, we have learned about the symmetrical fault. We have also seen the classification of the faults into the symmetrical and the unsymmetrical fault. In case of the symmetrical fault, we have seen the three-phase and three-phase to ground fault. So these were the two faults that we had seen in the um, symmetrical fault, and today we are going to solve a few problems related to the unsymmetrical fault. We are going to take some examples which are being asked in the previous GATE question papers. So the question which is on your screen here is asked in GATE 2016 question paper for 2 marks. So the question is in this way: two identical unloaded generators are connected in parallel as shown in the figure. Both the generators are having positive, negative, and zero sequence impedances of J 0.4 per unit, J 0.3 per unit, and J 0.15 per unit, respectively. If the pre-fault voltage is 1 per unit for a line to ground fault at the terminals of the generator, the fault current in per unit is dash. So in this year's question paper, no alternative is being given to you. They have asked you to calculate the fault current and write it over on the blank space. So the questions, the paper is online paper, so there will be a space provided to you, and in this space you will have to write the answer. So we have seen what is the LG fault in the previous lecture, and in the line to ground fault we have seen that the equation of the fault current is IF is equal to 3 into E upon Z1 plus Z2 plus Z0, where Z1 is the positive sequence impedance, Z0 negative sequence impedance, and Z0 is the zero sequence impedance. So you can see here the diagram is given here. So the two generators are connected in parallel with each other. So you can see here these are the two generators which are connected in parallel with each other, and this both these generators, the impedance ratings of these both generators are same, because in the question it is given two identical unloaded generators. That means both these generators are identical in nature. So what do we mean by identical in nature? The meaning of here identical in nature is everything will be same for the both the generator. That is, their MVA rating will be same, their impedance rating will be same. Only the connections that are different, that is given over here. So you can see here the connections that is given is star for the first one, and the star point is connected to the ground, or in other words we can say it is solidly bolted. So when we say that it is solidly bolted, we mean to say that the star point is grounded with the help of either it is connected with the help of a resistance, reactance, or it is solidly bolted. That the way which is the way in which it is given here, you can see here, this is a solidly bolted connection over here. So whenever such type of combination is given, the meaning of such type of combination is it is solidly bolted. So two generators are in parallel with each other. We can give any one as G1, any one as G2. It's our choice. We can give this one as G1, this one as G2, or we can give this one as G1 and this one as G2. It's one and the same thing. So uh, the given data, you can see what are the given data. Let's see one by one what is the given data. So the given data is the uh, impedances that is given. So you can see here what is the impedances given. Impedances are J 0.4 per unit, J 0.3 per unit, and J 0.15 per unit. So these are the three impedances which is given to us.
The three impedances, the first one is correspondingly the positive sequence, second one is negative sequence, and third one is zero sequence. So what are we asked to calculate? We are being asked to calculate the fault current when a line to ground fault is occurred at the terminals of one of the generator. So is the question clear to everyone? What is the question? See, it's a 2 marks question and you have to write it in the fill in the blanks format. No alternative is provided to you. So naturally you will have to calculate this first of all in your calculation part, and then whatever answer you get, that is to be inserted in this fill in the blanks part. So the formula you all know. What is the formula? Formula is 3E upon Z1 plus Z2 plus Z0. This is the formula for the fault current. So what is the E? The value of E is the pre-fault voltage. So here it's very specifically given if the pre-fault voltage is 1 per unit. That means they have already provided you the pre-fault voltage, that is E, that is 1 per unit. That means how your equation will convert now? Your equation will convert now. IF is equal to 3 multiplied by 1 upon Z1 plus Z2 plus Z0. So this is the equation that you have with you. So naturally now you will require Z1, Z2 and Z0. Please make it very much clear that the Z1, Z2 and Z0 are not these values as it is supplied in the question. So you should be very careful. Don't just put these values because the power system diagram is given here. So if the power system diagram is given to you here, first of all you will have to draw the positive sequence, negative sequence and zero sequence reactance diagram. Substitute the values which are given here one by one as positive, negative and zero, and then calculate Z1, Z2 and Z0. So is it clear everyone? Is it clear to everyone? How do we calculate Z1, Z2 and Z0? How do we calculate Z1? For Z1, what do we have to do is we have to draw the positive sequence reactance diagram. For Z2, we have to draw the negative sequence reactance diagram. And for Z0, we have to draw the zero sequence reactance diagram. All right, so is it clear everyone? So I hope you will be able to calculate Z1, then Z2 and then Z0. So what I will do is I will give for you the diagrams one by one. So the positive sequence, negative sequence and the zero sequence reactance diagram. So the positive sequence reactance diagram is in this way. So you can see here there are two generators. So I have given this generator as G1, this generator as G2, and the value corresponding to the positive sequence is J0.4. So this is already provided to us in the question itself. So in the question itself, we are being provided with the value of J0.4. So this is your positive sequence reactance diagram. Similarly, in the negative sequence reactance diagram, what we draw is we short this G1 and G2. So this G1 and G2 will not be present in the negative sequence reactance diagram. So this is your negative sequence reactance diagram. You can see here the value has replaced here. The value which is given in the data sheet is J0.3. So that's why I have written here J0.3. And similarly, we have to draw the zero sequence reactance diagram. So the zero sequence reactance diagram is in the last part which is given here. You can see here the zero sequence reactance diagram. Here I have written the value as J0.15. Now the question is why I have not connected this J0.14 to the reference bus, because here it is a star connection and the neutral star point is not connected to the ground. So if it is not connected to the ground, so we have to keep it in this way because this reference bus indicates the ground portion. So is it clear everyone? Please draw all these three diagrams. Then we will calculate one by one Z1 from this positive sequence reactance, Z2 from this negative sequence reactance and Z0 from this zero sequence reactance. So please draw this diagram. So once we are drawn with this diagram, then we will calculate Z1, Z2 and Z0. Once we are done with the calculation of Z1, Z2 and Z0, then we can calculate the fault current accordingly. So please draw this diagram. Those who have joined late, I will be showing the question after the solution of this problem, because we have almost done half of the problem. So those who have joined late, they have to wait for some time for the question part. So they can draw this. After drawing this, we will complete the fault current, and then I will show once again the question part. Okay, so is it done? Has everyone drawn the diagram? Shall we now solve for the Z1, Z2 and Z0? Okay. So you can solve for Z1 and reply what is the value of the Z1, because it's very simple. You can see here, in case of Z1, what do we have here? In case of Z1, we have J0.4 and J0.4 in parallel with each other. Somant, why you have presented your screen? Soman Durge, why you have presented your screen? Can you stop presenting? So is my screen visible to everyone? Is my screen visible to everyone? Because Somant have shared the screen. So please reply, is my screen visible to everyone? Others, please reply, is my screen visible to everyone? Okay, very good. So what we have here, we have drawn the positive sequence, negative sequence and the zero sequence reactance diagram. Now let us see the question once again, so that if the question is clear to us, then we can solve the question accordingly as it is asked in the question paper. So the question is in this way: two identical unloaded generators are connected in parallel as shown in the figure. both the generators are having positive, negative and zero sequence impedances of J 0.4, J 0.3 and J 0.15 per unit respectively. If the pre-fault voltage is 1 per unit for a line to ground fault at the terminals of the generator, the fault current in per unit is dash. So this is what the question is given. So and the power system network diagram is also provided. The diagram is in this way. So with the help of this given question and the diagram, what we have drawn the positive sequence, negative sequence and zero sequence reactance diagram. So this is what we have drawn with the help of this particular diagram. So this is our positive sequence reactance diagram. This is our negative sequence reactance diagram and this is our zero sequence reactance diagram. So from positive sequence reactance diagram, we will get Z1. From negative sequence, we will get Z2. And from zero sequence, we will get the Z0 part. So once we get the Z1, Z2 and Z0 part, then we have the equation for the fault current. The equation for fault current is IF is equal to 3 multiplied by E upon Z1 plus Z2 plus Z0. So once we get Z1, Z2 and Z0, then we can get the values for the uh, fault current. So that is what is asked in the equation for the fault current, right? So so can anyone calculate the Z1 value and reply on the chat box for the Z1 part, Z2 part and Z0 part? So as far as Z1 and Z2 is concerned, it's very simple. The parallel combination of these two branches is given. So one branch is having J 0.4, the second one is having J 0.4. So you know how to do the parallel combination. So calculate it fast and reply on the chat box what will be the value of Z1. Similarly, for Z2, we have J 0.3 and J 0.3 again in the two branches. So again calculate for Z2. Very good. So Kajal has replied J 0.2. Right. So J 0.2 is the correct answer for Z1. And for Z2, again, there is a two parallel combination. The parallel branches are J 0.3 and J 0.3 again. So please calculate it and reply on the chat box what will be the value of Z2. So in this way, we will get Z1 and Z2. Then we have to calculate the value of Z0. Very good. So Z2 is J 0.15. So then we come to the zero sequence combination. So you can see why we have drawn the zero sequence combination in this way, because the generator G1 is connected in the star fashion and the star point is connected to the ground. That's why we have connected to the ground here. But here there is no resistance or reactance value. That's why we have kept it blank here. Why? Because if there would have been a value here, then we would have taken here and multiplied it by 3 as we used to do in the previous problems. And in case of the second one, that is the second generator G2, you can see here there is a star fashion connection, but the star point is not connected to the ground. So that's why we have also not connected to the ground. We have kept it open. So when we want to calculate the equivalent or rather Thevenin's equivalent of this zero sequence reactance, we have to consider only one branch, that is the J 0.14 branch, because this second branch J 0.15 is not coming into picture. Why? Because it's not getting connected with the reference bus. So it's a open bus. So this part is, oh, this branch is open. That's why this part will not come into picture. We will have only one branch, that is J 0.15. So in this way, what we are going to do is now we are going to calculate the Z1, Z2 and Z0. So Z1 will be J 0.4 in parallel with J 0.4. Naturally, the value is J 0.2. Then for Z2, we have J 0.3 in parallel with J 0.3. So that comes to J 0.15. And then for Z0, we have only one branch. So that's why the value comes to J 0.15. So now we have the formula available with us. What is the formula? Formula is 3 multiplied by E. What is E? E is the pre-fault voltage. So pre-fault voltage is already provided in the question. If you will read the question properly, you can see that it is given as 1 per unit. So this will be 1 upon 0.2 from here Z1, 0.15 from here Z2 and 0.15 again from Z0. So in this way, we will substitute the value of all the system here and we will calculate the value for IF. So please calculate and reply on the chat box what will be the value for IF. So make the calculations fast and reply on the chat box what will be the value for IF. So anyone has got the answer, please reply fast. Okay. 6 ampere. Kajal, it's not ampere because all the values that you have here is in terms of per unit, right? So it will not be in terms of ampere, but it will be in terms of per unit. Is it clear, Kajal? So please remember you all are calculating all the values in terms of per unit and not in terms of the actual value. So when you have the actual values with you, at that time you can multiply this base values with the actual current, then you will get the actual current in terms of ampere. But here as you are calculating everything in per unit system, that's why you need to write the answer in terms of per unit only. So that's why we get here the answer as 6J per unit. So this is what is asked in the question paper. So we have just now solved, excuse me, we have just now solved a question related to the fault current in case of line to ground fault, which was asked in the GATE 2016 question paper for 2 marks. So we will again see one more time the question and then we will go to the next question. So this is what the question is. So positive, negative and zero sequence values were given. Then we have converted this power system network into its equivalent reactance diagram, positive, negative and zero sequence. So this we did and then we calculated Z1, Z2 and Z0. Then we inserted into the formula and we got the result as 6J per unit. Alright, so shall we proceed for the next problem? Okay, so let's see the next problem. So this is the next problem. Please note down the question of the next problem. So this is our next question, which is asked in GATE 2014 examination for 2 marks. So note down the question, then we will solve this question and we will see how we can easily solve these questions which are asked for 2 marks in the power system, electrical power system part in the GATE exams. So in every gate exam, you will be finding one or two questions related to this type of faults, either symmetrical fault or unsymmetrical fault. We have already seen the symmetrical fault in the previous lecture. Now today we are solving the problems related to the unsymmetrical fault. Okay, so let us read the question and understand the things what are asked in the question. So, in the question, what is asked is a three-phase 100 MVA 25 kV generator has solidly grounded neutral. The positive, negative, and the zero sequence reactances of the generator are 0.2 per unit, 0.2 per unit again, 0.05 per unit, respectively, at the machine base quantities. If a bolted single phase to ground fault occurs at the terminal of the unloaded generator, the fault current in amperes immediately after the fault is dashed. So in this case, you have to calculate the fault current in amperes. So now you have to be careful. In the previous problem, what we did was, in the previous problem, we have solved the answer in terms of the per unit quantity, because the actual quantities were not provided to us in the previous problem which we solved just now, which was asked in GATE 2016 question paper for 2 marks. Now here in this case, question in 2014, the actual conditions are given to us. So the actual conditions or actual ratings are 100 MVA to 25 kV. So as the actual ratings are provided to us, it's easy for us to calculate the actual fault current in terms of ampere. So even though the values for the positive, negative, and the zero sequence reactance are given in per unit, we can first calculate the fault current in terms of the per unit system, and then we can multiply the per unit value with the base value which is provided to us here in terms of the ratings of the generator. Then we can get the we can get easily the required answer, that is in terms of the ampere. So if you are able to solve it, please start solving it. If you are not able to solve it, please make it here. I will solve it. So let's see one by one. So we have the equation for the fault current in case of a single line to ground fault. You can see here the type of the fault which is given here is if a bolted single phase to ground fault occurs at the terminal of the unloaded generator. So it's very much clear that the type of fault which is given in this problem is a single line to ground fault. And if a bolted single line to ground fault is given, so what is the meaning of bolted single line to ground fault? The ZF part will not be here. So we have the generalized formula for the line to ground fault as 3 times E upon Z1 plus Z2 plus Z0 plus ZF. But as the question in the question itself, it is given it's a bolted single line to ground fault. So ZF portion will not be given here, or in other words, ZF will be equal to 0. So that's why we will be solving here with consideration as ZF equal to 0. Our formula will be in this way. So IF is equal to 3 multiplied by E upon Z1 plus Z2 plus Z0. So you have all the values available with you. The pre-fault condition we always take as E as 1 per unit. Z1 is given here. You can see positive sequence as 0.2, negative as again 0.2, and zero sequence as 0.05 per unit. So please insert into this formula and reply me the answer in terms of per unit related to the value of IF. Okay, so someone has replied. Okay, Kajal again has replied. So anyone else who have got the results? Anyone else? You can make your calculations fast and cross check the answer which is given by Kajal. Okay, so let's see how the calculations will go. So we have this value. So you can see here as it's given as reactances. That's why I have taken here J. But then in the next part, you can take only the magnitude part because we are interested in the magnitude part of the current. So you can then limit your answer with the magnitude only. So the answer is 6.66 per unit, right? So this is the per unit value. So now this is not being asked to us, right? What is asked to us? We are being asked to calculate the value in terms of the ampere rating. So you can see here the fault current in ampere. Fault. Please mute your mic. Okay. So so we have calculated the answer in terms of the per unit, right? So but in terms of per unit they have not asked you. What they have asked is they have asked in terms of the ampere rating. So how will you get the value of the current in terms of ampere rating? For that you need to calculate the base current. For the base current, you all know what is the method. The method is to have the calculation as MVA divided by root 3 multiplied by the voltage rating. So this is what the procedure that we follow in order to calculate the base current. So let's calculate the base current now. So base current will be MVA rating is given as 100. So 100 into 10 raised to power 6 I have taken upon root 3 multiplied by you can see there what we have written. We have written 25 kV. So 25 kV means 25 multiplied by 10 to the power 3. So in this way you will get the base current. So the value for the base current is 2309.40 ampere. So once you get this base current, it's easy for you to calculate the actual current in this way. So in case of the actual current, we will have uh, the actual current as the base current multiplied by the per unit current that you have obtained. So please calculate and reply on the chat box what will be the value of actual current in terms of ampere. So in this way, you will get the result for the fault current in terms of the ampere rating. Okay, so 15,15380.61. So this is the correct answer. So we have to round off and we have to write it 15381 ampere. So please be careful whenever such type of questions will be there in the gate examination. Whenever fill in the blanks type question will be there, you have to write the answer in the correct form. So if it's written that you have to write the answer in the decimal point up to 2 digits, you can write this answer, that is 15380.61. If it's written that no decimal point will be allowed, you have to round off the value, then you have to write the result as 15381. So is it understood to everyone? Whenever such type of questions will be there, where the fill in the blanks will be given to you. So in such case, what you have to do is you have to read the question very clearly. If in the question it's written, write the answer up to 2 decimal digits, then your answer will be this one, the first answer, that is 15380.61. If it's written that you have to round off the answer, then you have to write 15381, because you can see after this point there is 6. If you round off this 6 to this one, it will be 15381. So in this way, we get the result, actual result in terms of the ampere, which is asked in the question paper. All right, so is it clear everyone how to solve the questions or how the questions are asked in the gate question paper related to the unsymmetrical fault? So it's very simple questions are asked. You just have to remember the formula which are used for the calculation of the various fault currents, and then you can very easily solve the problems. We will take one more question. This will be a homework to all of you. You have to do a little bit homework related to this and solve the answers in the reply me the answers in the next lecture. So you can see here the solution part I have kept it blank. So the question is the sequence components of the fault current are as follows. I positive is equal to J 1.5 per unit. I negative is equal to minus J 0.5 per unit. I 0 is equal to minus J 1 per unit. The type of fault in the system is LG, LL, LLG or triple LG. So this question is also asked in one of the gate question paper. I somehow missed to um, write the year in which it is asked, but it's asked in the gate question paper itself in the previous year's question paper. So you have to compare the fault current in terms of the I positive, I negative, and I zero, and then you have to reply what will be the answer to this. See, it's very simple. In a very simple way, I will give you a hint for this question. So we have already derived the uh, formula for the LG fault. So in case of a LG fault, you all know that the positive, negative, and zero sequence current are same, right? So you all have already written the formula, that is IR0 is equal to IR1 is equal to IR2 is equal to E upon Z1 plus Z2 plus Z0 plus 3ZF, right? So in case of LG, IR0, IR1 and IR2, all the three are same. So definitely LG is not the correct answer, right? So LG is definitely not the correct answer. Then when we come to the third last option, that is D, triple LG. What is triple LG? Triple LG is nothing but the three phase to ground fault, right? So in case of a three phase fault or three phase to ground fault, you all know that only positive sequence component is present, right? So in case of a symmetrical fault, only the positive sequence component are present, negative and zero sequence component are not present. So naturally LLLG, that is triple LG or three phase to ground fault, is also not the correct answer. So then you have only your option left with LL and LLG. So I am giving you the hint to solve this question, or rather how to solve the questions in the gate paper. So whenever you analyze the options available with you, you have to recollect all the formulas that you have learned. So in case of a LG fault, all the sequence component are same. In case of a three phase to ground fault, the in case of a three phase to ground fault, the sequence component are not same, but then in case of a three phase to ground fault, only the positive sequence component is present, negative and zero sequence component are not present. So naturally A and D is not the correct answer. So then you are left over with two component, that is LL and LLG. So you have to check with the positive, negative and zero sequence current for fault current equations and compare the values which is given here, and then to solve the correct option from B and C. So out of this B and C, one will be the correct option. You have to take it out how the correct option is to be searched. We will be taking this in the next lecture. So just wait for a minute. I will share the attendance link. You will have to give the attendance in the attendance link. It's mandatory to give the attendance as we are monitoring the attendance for your further actions. So attendance link is circulated. Please give your attendance. Thank you everyone. See you all in the next lecture.